Hey, 8th grade. Today we're going to be talking about perfect squares and perfect cubes. Don't worry about those virtual class norms. Those will be used tomorrow when we meet virtually tomorrow. I said tomorrow too many times. Anyway, here's your warm-up. Get started. So pause the video. Finish that warm-up. When you're ready, unpause the video. All right. Let's go over. So we're going to go over some perfect squares. I'm going to just jump right down here, and I'm going to list them all from what we did yesterday. So if any of these numbers that you got would be correct, okay? So we got 1, 4, 9, 16, 25, 36, 64, 40, oops, my bad, I skipped one. 49, 64, 81, 100, 121, 144, 169, 196, and 225. If you got any of those numbers for the warm-up, that is correct. This, to create a perfect square, you're just squaring a number, right? So for this one, for 1, it was because 1 squared, right? 1 times 1. 2 squared to get 4, 3 squared to get 9, 4 squared to get 16, 5 squared to get 25, 6 squared to get 36, 7 squared to get 49, 8 squared to get 64, 9 squared to get 81, 10 squared to get 100, 11 squared to get 121, 12 squared to get 144, 169 is 13 squared, 196 is 14 squared, and 225 is 15 squared. That's it. Okay, those are perfect squares. All of these numbers are perfect squares, okay? And they're perfect squares because you're multiplying a number by itself to get that number. It also represents the area of a square, and it also helps us with something called square roots. If you have not taken these notes down, please pause the video and make sure you have done so. But here we're going to take a close at square roots. Square root is a factor, right? A factor of a number that when multiplied by itself gives the original number. For example, both 3 and -3 are square roots of 9. A factor, right? A factor of, let's say, 24 is 6 because 6, so a factor, sorry, I'm going to need a full sentence here. A factor of 24 is 6 because 6 goes into 24 evenly. That's what a factor is. And that's kind of what's happening with a square root. So when we take a square root of a number like 25, we're asking ourselves, what number squared or multiplied by itself is 25? So when we think about it, what number times itself is 25? 5. And that's because 5 squared, which is the same thing as 5 times 5, is equal to 25. There is another answer here. Square root of 25 also can equal -5. And that's because -5 squared, which is the same thing as -5 times -5, is equal to a positive 25. So the answer here is actually both 5 and -5. To write that, we can do the following notation. We can either do 5 and -5. I've seen 5, comma, -5. I've also seen this one, which is my personal favorite, a plus and a -5. This is actually the one that you're going to see probably most common in textbooks and in high school. I have also seen someone use a set notation, but this is the one that I will be using mostly. So let's take a moment and practice a couple square roots, why don't we? Okay, we got square root of 9, square root of 36, square root of 196, square root of 1, square root of 2, and square root of 3. I want you to try that on your own, so pause the video and get started. Once you're ready, unpause, and we will continue. All right. Square root of 9 is positive and negative 3, because positive 3 times positive 3 equals 9. Negative 3 times negative 3 is also equal to 9. Square root of 36, positive and negative 6. 6 times 6 is 36. Negative 6 times negative 6 is also 36. 196, plus and minus 14. 14 times 14 is 196. Negative 14 times negative 14 is also 196. Square root of 1. Negative and positive 1. 1 is a perfect square, so that works. Okay? 1 times 1 is 1. Negative 1 times negative 1 is 1. So square root of 2. Weird, because that's not a perfect square. There is no whole number when multiplied by itself gives you 2. Well, actually, when you type this into the calculator, you're going to get a really long decimal. You're going to get something like 1.414. I'm going to double check myself. I think I got that. I usually memorize these. I'm rusty. Out of the school. Yes, 41421 ... Goes on forever. Okay? Same thing with the square root of 3. That is not a perfect square. So when we take the square root of that, it's 1.73205 ... Right? Do you remember what we call these types of numbers? These numbers that are decimals but go on forever and there's no pattern to it. Anybody remember? Irrational. These are irrational numbers. And it's kind of silly to write the irrational number with all those decimals, right? All those numbers. So actually, the way we write the decimal, the way we write this, we just leave it like square root of 2, square root of 3. So you can leave square root of 2 just equal to square root of 2. Like there's no other better way to do it. Kind of like pi. You remember pi? Pi is an irrational number. Pi is equal to 3.1415962, blah, 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 blah. Goes on forever. But we write it as just the symbol pi because that is the best representation of that irrational number. Same thing with these square roots. Okay? These square roots that we've dealt with before, 9, 36, 196, and 1. Those are perfect squares. And that's where square roots are awesome. When we have a perfect square, it's going to equal a whole number. When we don't have a perfect square, a square root's always going to be irrational. So let's write that down. The square root of a number that is not a perfect square is irrational. Okay? Now, one last thing about square roots, and I may have slipped this word in there. I interchange it. Another way to say square root is radical. So you can actually call a square root a radical. So even though, let's take a look at this one, we could say this two ways. We could say this as the square root of 25, or we could say it as radical 25, right? Just like over here, we could say radical 2, and this could be radical, that one could be radical 3, okay? Those are interchangeable. You can use either word. Next, cubes. Yesterday we did more perfect squares. Now we're going to do perfect cubes. So this time it's not just about area. We're talking about volume. Okay? We're talking about volume. So let's take a look at this number 2. We're going to look at this one first. So remember, in a cube, the side lengths are the same. There's 3 of them. We got the height, the length, and the width. Yeah, they're each 2, right? 1, 2, 1, 2, 1, 2. So the side length is 2 units. The volume, remember, when we're doing with a cube or a rectangular prism, is length times width times height. So that's 2 times 2 times 2, which is the same thing as 2 cubed. See where we're going with this? And that's 8. Now in this case, it's 8 cubic units. right? How many actual cubes make up that bigger cube, right? It is 8, not 4. Not 6, I'm sorry, not 6. Everyone thinks 2 to the third is 6. That is not true. No. That is an oh no. When you look at 2 times 2 times 2, you do 2 times 2 first, which is 4, times 2, which is 8. Oh no. Do not multiply the base and the exponent. Don't do it. 2 to the third is 8. Let's go to the next one. What is the side length of this cube? 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Side length is 3 units. The volume, again, is multiplying all the sides. And we have 3 times 3 times 3. Which is the same thing as 3 cubed, which is 27 cubic units. It is not 9. Everyone thinks it's 9. It's not 9. 3 cubed is 27. Again, 3 times 3 times 3, 9 times 3, which is 27. It's an oh no. Make sure you're multiplying all them out. If you're not sure, use a calculator. Don't guess. Don't guess. What about this big one? Yeah, it's a 4 by 4 by 4. Our side length here is 4 units. Our volume is 4 times 4 times 4, which is also 4 cubed, which is 64 cubic units. 4 times 4 times 4. 4 times 4 is 16 times 4, which is 64. Not 12. Great. Let's go back to that first one. What about this first one? Easier than you think. Easier than you think. Yeah, it's just 1 unit. So 1 by 1 by 1. That means the volume is just also 1. And that's it. Nice. These numbers that you see here, 1, 8, 27, 64, are known as perfect cubes. Here's the definition of perfect cubed. Perfect cube is the product of a whole number multiplied by itself 3 times. For example, 64 is a perfect cube because 4 times 4 times 4 is 64. So let's go through these. We're actually going to go through some perfect cubes. Okay, we're going to do the same thing as we did yesterday. We're going to make a nice little chart. Do the same thing over here. Okay, so here would be 1 cubed, which is 1 times 1 times 1, which is 1. 2 cubed, which is 2 times 2 times 2, which is 8. 3 cubed, which is 3 times 3 times 3, which is 27. I think you got the hang of this. Why don't you take a pause the video, and go through it on your own. When you're ready, unpause it, and we'll go through it together. Okay, this is 4 cubed, which is 64. 5 cubed, which is 5 times 5 times 5, which is 125. Keep that going. 6 cubed. Remember, you can always pause the video to slow down and make sure you're getting these notes. 6 cubed is 216. 7 cubed. 343. 8 cubed. 512. 9 cubed. 729. And 10 cubed is 1,000. Okay? All of these are considered perfect cubes. And that will lead us into our next thing called cube roots. Yes, there are such things as cube roots. Same idea as square roots. Okay? A cube root is a factor of a number that when cubed gives you the original number. For example, 3 is a cube root of 27. Okay? Let's take a closer look at that number 27. Right? This is asking us what number cubed or multiplied by itself 3 times is 27. There's only one answer for that, right? 3. Square root of 27 is 3 because 3 cubed, which is the same thing as 3 times 3 times 3, equals 27. Now, what about negative 3? Aha, negative 3 is not equal to the cube root of 27. And I apologize, I do this. I'm so sorry, I always forget this. When we're talking about a cube root, we always have to put a little 3 so we know the difference between a cube root and a square root. My apologies. So the cube root of 27 does not equal negative 3 because negative 3 cubed, which is negative 3 times negative 3 times negative 3, is not positive 27. If we look at this, this is positive 9, and that's negative. It ends up being negative 27. So we can't have a cube root that's a negative, okay? So a cube root cannot equal a negative number. Let's do a couple more examples. Cube root of 512, cube root of 125, cube root of 64, cube root of 1000, cube root of 3, and cube root of 7. Okay? So what's the cube root of 512? Well, let's look at our list. Is 512 a perfect cube? If it is, it's super helpful. It is. 8 cubed equals 512. That means the cube root of 512 is 8, right? And that's because 8 cubed equals 512. Why don't you try the rest of these? And when you're ready, unpause, and we'll work on it together. Okay, cube root of 125 is 5. And that's because, BC is because, 5 cubed equals 125. Cube root of 64 is 4. And that's because 4 cubed equals 64. Cube root of 1,000 is 10. Because 10 cubed equals 1,000. What about the cube root of 3? It's irrational. That's right. It's the same. It just stays there. Same thing with the cube root of 7. If you put that into a calculator, it would be an irrational number. Same idea as before. The cube root of a number that is not a perfect cube is irrational. And you just leave it written just like that. That's it for today. You have a Google form to fill out. That is your practice for today. Please read the instructions to the Google Classroom carefully. Okay, I would like you to submit your notes and just make sure you mark it done in Google Classroom so I know it's completed. Tomorrow I will see you virtually. Make sure you sign in with your DOE account. So when we meet tomorrow, make sure you log into TeachHub first, then go to Google Classroom from there. That's the best way to do it. If you have any questions, please let me know. And see you guys tomorrow. I'm very excited. Have a great one.